Hi everyone, welcome and thank you so much for joining my presentation about why agile engineering practices are essential to achieve agility in software development. And most importantly, why everyone should care about this, and not only the team members or engineers. So first, let's talk a bit about me. I'm first and foremost a practitioner working in the field, so I actively work with teams, mostly in the Agile and Lean space, and also mainly with software development teams. I started my career in software development, I think around 2005, and I did a lot of different roles, QA, a Scrum Master, product owner, some coaching, just a lot of different things, anything to help a team, to deliver some awesome products. So I am, however, not a software engineer. I have never been. And I was one of those people who really completely misunderstood and underestimated the need for agile engineering practices. I really had to learn the hard way that without it, you cannot really achieve agility. So over the years, learning that lesson, as I said, the hard way, it turned into a topic that I'm now very passionate about and I would like to share about. But on my profile, it shows I'm a Scrum.org trainer and I'm also a Kanban University trainer. And although I am that, I also want to emphasize that I'm not bound to a certain framework or a certain method or just one way of working. Instead, I really believe in a pragmatic approach. Yeah, so really thinking within context. What works for one team could be just absolutely unsuitable for another team. So I love learning. I like to take my learnings from a wide spectrum of areas. I mix ideas and then together with my team members, I experiment. And sometimes we hit the jackpots. And we're doing really something, we experiment with something that is actually really good for us and really works for us as a team. And other times it's, it doesn't go that well, and it goes horribly wrong. But I guess that's all part of the journey and you learn from it. I love to travel. So just before COVID hit, like in 2018, my partner and I, we traveled around the world. So we traveled for about 8 to 9 months, and we traveled to South America, Southeast Asia, and Europe. And part of that journey was that we really wanted to research how different cultures, impact how we adopt Agile across the world. So we visited loads of teams and organizations adopting Agile, and we had a lot of conversations and we did research. And when we came back to the UK, because I currently live in the UK, we had a lot of data and a lot of things to share. So we decided to write a book. We took our chances, asked the publisher if they were interested, and luckily they were. So our publisher, Apress, published our book, Adopting Agile Across Borders. And they did publish that in 2021. Very recently, only like last month, we just published our second book, which is Mastering Collaboration in Product Teams. And we did that in collaboration with one of our product designers. I work for a company called Red Tangerine. And if anyone wants to have a chat with me after this talk, for example, via email, they can contact me on this email address or just connect with me on LinkedIn. I'm usually reasonably good with coming back with messages. I would say that's more than enough than talking about me. So let's just start. So let's start with the term agility. So in the Oxford Diary, the word agility is described as the ability to move quickly and easily. So looking at the description from that dictionary, I'm actually not surprised, and I find it understandable that many people relate agile and agility to speed, which personally I think is a bit unfortunate, but it's also understandable. So I really prefer this description, which comes from Shepard and Young, and they use this in the sports community. Yeah. So a rapid whole body movement with change of velocity or direction in a response to a stimulus. What is meant by agility and change of direction speed are often used interchangeably. However, there is a distinct difference between them. Agility involves reactive abilities in an unpredictable environment. Change of direction of speed, on the other hand, focuses purely on maintaining speed as the direction of travel is changed and is usually performed in pre-planned environments. So let's take a step back and just give a few examples. For example, using a sports analogy, using football, we would say a defender's reaction to an attacker's sudden movement is an agility-based movement. They have to react based upon the attacker's movement. On the other hand, when an athlete, has to zigzag through a set of pre-positioned cones that are put out there, then that reactive component that we saw in the previous example is missing. There will be no impulsive movements they have to react to. In this example, we talk about change of direction of speed. More and more companies are adopting Agile. And in my opinion, we may have crossed the chasm. It's becoming more popular. This growing popularity does also mean that sometimes companies may dive into big Agile transformations, or they start, adopting Agile for reasons that may not live up to their expectations. As an example, often when asking leadership why they want to adopt Agile, why are they doing these big Agile transformations? And the answer is more around the line of, we want to deliver faster. In that case, I would say they're referring to increasing the speed as they change direction. It's instead of agility, what they're talking about. So using the athlete analogy again, they talk about the athlete reaching each cone as fast as possible and then move in the direction of the next cone and again get there as fast as possible until they reached the end of the track. So how we can see that in software development is like, for example, a project is set. Yeah, a team starts a new project. They have got a list of things, a list of features they want to be part of that project. And a team works on short iterations, maybe short sprints, just like the cones. Yeah, and in which they deliver the planned features that, that were set. And they want to deliver that as fast and efficiently as possible. Sometimes if there's a deadline, they drop some of the features, but in no time do they really stop, validate if the features are actually valuable, if they are still building the right things, if they actually should pivot and maybe even abandon the project, or that they should go in a completely different direction. So that may be absolutely fine if you're working in a predictable environment where requirements don't really change, customer behaviors are really very stable, the market stays the same, etc., etc. However, in a unpredictable, so-called VUCA environment, there is a need to be able to react to new information, to validate assumptions frequently and get regular feedback. We need to be able to inspect what's going on in the market, what our competitors are doing and how customer behaviors change, and we need to be able to adapt to this. We need to reduce the risk of building the wrong stuff. So in a nutshell, in those kind of environments, we do need agility. Now, frameworks such as Scrum are really originally meant to support agility. It has its foundations based on empiricism. Sprints are short, so we have greater transparency. We can inspect and adapt based on that feedback, based on the trends, etc., and changing conditions. It will give us an opportunity to pivot and react in a timely manner. However, there's a however again. Unfortunately, what we often see is that Scrum is misunderstood or misused as just a mechanism to deliver faster. So over the years, I've encountered many agile adoptions at companies where a lot of energy, focus, passion, and budget went into training and coaching people in implementing certain frameworks, like Scrum. But it could also be, I see Spotify models, Safe, I've seen all kind of flavors around. The goal there was to understand and ensure that all the framework elements are in place, such as the required collaboration meetings. Do we have the right team structure? Do we have cross-functional teams, etc.? It often involves people participate in numerous workshops about their agile ways of working. What I encounter less is that companies spent the same amount of passion, energy, budget, and time in helping ensure teams have the time and ability to use good agile engineering practices as part of their day-to-day job. There may be, like, as part of their agile transformation, there may be some like initial like investment, like the build pipeline, some DevOps practices. But then when it comes to the actual day-to-day engineering practices, that often takes a backseat. And it's usually under the mantra of like, oh, we don't have time for that now, or let's just deliver this first, get this release out of the door, and then we can have a look at a later stage when we have time. And in reality, often that time just never arrives. Sometimes people do not see the need, or they don't realize that without agile engineering practices, they will eventually actually slow down. So in the long run, they will neither increase or maintain a change of direction of speed, let alone be truly agile or achieve agility. Teams come under more pressure to go faster, deliver more, and they consciously or subconsciously start to trade quality for speed. Technical debt builds up, and really until it becomes unsustainable. I have a short little nice video, a bit of fun, that talks about technical debt and how it becomes unsustainable, and it's a little video of my dog Fred, and I'll show it here. Okay, so of course this is a very simplified example, but maybe it shows you in a fun way what can happen if we just focus on speed of delivery. We know that we should do things differently, but we feel that getting things done, or we feel pressured to get things done out of the door fast, is more important than actually doing it properly. I do want to talk a bit about an example that happened to myself and my team members. And this was my very, very first team that I worked in. And that was in 2005. I just started my career in software development. And I was a team member that had a specialism, in QA. We were a completely new team, working on a completely new product. So we're just building it up from scratch. And on top of that, everyone was new to Scrum. So we decided we would actually try the Scrum framework, and we were all new to it, and it was all quite excited. It sounded like an exciting journey. Our goal was to build an e-commerce site, and back then I think we didn't have that many choices than you have now, when you have a lot of off-the-shelf e-commerce platforms that you can use. But back then there was not that many out there, so we decided to build it ourselves from scratch. We also decided to use 1 month sprints, which was quite revolutionary. Nowadays, a lot of companies, when they do Scrum, they do 2-week sprints. But back then, 1 month was already like quite short, to start with. And our first slice of functionality that we wanted to deliver was a catalog page. Just almost like a static page on the e-commerce sites or on a site. We could upload some pictures, a short description, and a telephone number that people could reach if they had a question about the product. So there was nothing like interactive yet. You couldn't buy anything yet. There was just the first slice. So we did that for 1 month, and we designed, developed, and tested everything in 1 month. And we delivered it, and we were delighted. We loved it. We felt good. Our first delivery was also received by excited stakeholders. They were happy, and they were hungry for more. So they were excited to see progress. They were excited to see things already like live and production, but they really wanted more. And since we learned that one of the Agile principles was like satisfy the customer, we were more than happy to oblige. We kept on building, and our product kept on growing. The more stakeholder requests that came in, the harder we worked to deliver at a pace that we felt was expected. We did not have time to invest in automation or agile engineering practices. We were way too busy manually regression testing everything manually in order to continue to deliver, in that short time box. The bigger, or maybe I even should say, the more bloated the product became, the more we struggled to deliver at the same pace, to try to meet the expectations. And we began to cut some corners. We kept on telling ourselves that now was not the right moment to put those technical practices in. It was not the right moment to shift to the left, like building in quality. We were just too busy firefighting on the right. We ended up running mini waterfalls, carrying over testing work from one sprint to another, and validating if we were actually delivering the right work, if it was actually valuable to the customer, and if it was even used by customer, was far from our minds. We were just so focused on delivery. After some time, it did become very clear that we had delivered a lot of features that people just never used or barely used. And because they were in our code base, it made our product harder to maintain. In the meantime, whilst we were so busy churning out all those features and carrying out manual integration, regression testing, etc., we did not have time to look into our deployments. How can we improve our deployment processes? How can we improve the way we release? So releasing to customers meant our website had to go down for hours on end. And that wasn't really acceptable, during the time that people were buying products. So we had to do overnight releases. So the team had to come in during the night for hours, doing a lot of manual work, and the website would go offline. So we ended up with quite an exhausted team. There was a lot of overhead, because if you work overnight, you can't work the next day. You just tie it for the next 3 days. So it wasn't really an ideal situation. Now, to make matters worse, the market changed, like the trend in the market changed significantly as well. And our salespeople saw that the biggest opportunity was actually selling our product to companies in completely different time zones. So our out of hours release window went kind of out of the window, really. It didn't no longer existed, because what in the UK, if we did an overnight deployment to production and the website would go down, that means in another part of the world, it was during the day when people actually needed to use our platform. So it is fair to say, let's go back. So it's fair to say that after so many sprints, we were like almost to the standstill. We're in over our heads with technical debt. We lost transparency. We lost the ability to get early feedback because we couldn't get anything out. Therefore, we also lost the ability to pivot. And we couldn't react anymore what our attackers were doing, our attackers, our competitors. So we couldn't even take advantage of those market trends that our salespeople identified, like these markets in those different time zones at the other end of the world. Now, of course, nothing stops us from adopting frameworks such as Scrum without agile engineering practices. After all, if we think about it, Scrum is just a framework. Yeah, so you've got your sprint events, you've got your accountabilities and artifacts. So Scrum, really, in the Scrum Guide, we're not talking about all the complementary practices that you may want to include on top of the framework. So practicing Scrum without good engineering practices and without striving for technical excellence will only get you so far. And in my experience, it will not take too long before a team really becomes overwhelmed, like what happened in my team's example. Just implementing the mechanisms of Scrum just doesn't ensure agility. The Agile Manifesto includes principles such as continuous delivery of valuable software, continuous attention to technical excellence, and at regular intervals, the team reflects on how to become more effective. Yeah, so continuous improvement. So in my opinion, following these principles are a greater enabler of agility than following the Scrum framework just on its own. So, okay, so we talked a bit about what agility is, and I think we, talked a bit about like how important those agile engineering practices are, and to enable us to pivot. So let's have a look at a few of those technical practices that could have helped my team back then to reduce risk and would have allowed us more towards agility. Now, I know there's many, many more practices out there, so these are just a small sample. Many of these practices you can track back to Extreme Programming, XP, by Ken Beck, Ron Jeffries, and Walt Cunningham. So let's start with pair programming. Pair programming is not just, two people, talking to each other, working on one item at a time at the same computer. It does involve a bit more. So proper pair programming involves one person acting as the navigator and the other one as the driver. So, and only the driver touches the keyboard. So they're the only one using the keyboard and mouse, and the navigator directs them. It does involve a lot of communication between them. And it's not only about, producing code, but code with good design through real-time code reviews. Checks for conformance to standards, and reduced risk of inadvertently adding bugs or technical debt. So with two different perspectives of the driver and the navigator, so the driver can think about the small tactical tasks that they're working on, the task at hand, whilst the navigator can think of the bigger picture, so they can think strategically as well. On the other side of this slide, you will see something like ping pong pairing. And ping pong pairing includes test-driven development, which we usually abbreviate to TDD. So let's talk about TDD first, and then we come back to the ping pong. So TDD is a disciplined approach that follows the red-green refactor cycle. First, a failing test is written, and it fails because there's no code that actually solves the test. It's not there yet. So then just enough implementation of code is written to make the test pass. Once the test and other tests pass, we move into the refactor phase. The coder or coders look at the code and decide if it can be improved to make it more maintainable, cleaner, and easier to understand. Now, a good understanding of code patterns and principles can really help with this step. After refactoring, the test can be run again to ensure the functionality works as expected. Those tests form an insurance policy, allowing the refactoring to be done with confidence that nothing will inadvertently be broken. The design of the code is also driven by the tests. Now, this is particularly effective when tackling a complex problem, when there's no obvious design upfront. After the refactor step, the process is repeated with the next failing test and so on. So let's go back to the ping pong that we're talking about. So ping pong pairing is actually a technique which combines pair programming and TDD. So a bit in a nutshell how it works. You've got one driver, let's say person A, they are the driver, and they write a failing test, which is ping. Person B becomes the driver for the pair when writing the implementation to get the test to pass. Pong. Person B is then the driver for writing the next failing test. Ping. Now, each pong must also be followed by person A and B, refactoring the code together before they actually move on to the next failing test. And in that manner, they actually follow the red-green refactor approach. There are many, many benefits of pair programming, TDD, etc. So I'm just going to summarize a few of them. So one of them is actually sharing knowledge. It also removes bottlenecks in a team. It can increase flow. So it's not only one person who knows what the code does, etc. The two modes of thinking combined is very good. You've got the task at hand, the detail, but you also have got the strategic and the bigger picture thinking, those different perspectives. Different perspectives usually also come up with better solutions. There's collective ownership and focus. They're really focusing on what they're doing. You keep the work in progress low, so it actually increases the flow of the work in your team. And you will gravitate towards really good design patterns. Needless to say that this, of course, all increases quality with more cleaner and more maintainable code. Code reviews on the go. I think for me, this is a really nice one because one of the teams I worked with, they really had problems with code reviews with regards to they weren't really doing a lot of pairing together, and things would just be thrown into code review. Other people just were too busy to pick it up, so it could take days before it got picked up, and then it was being looked into, and then I had to change it, and it went back and forwards. And it's just, if we just had live code reviews, it would have gone so much faster, and also you would share so much better knowledge. So it results in good code coverage and in meaningful tests, and we're probably more likely to build the right thing. I do have to say, just like with everything we do, there are not only benefits, but there are also challenges. For example, pair programming, as I mentioned, one of the benefits is really good increased focus, but it does need focus, and it can be really, really tiring. On top of that, if you're like an introvert like me, You may understand that I'm someone who needs some time to reflect. I need time to recharge. So I'm absolutely a big fan of close collaboration, but I also need my individual space to reflect and to recharge. So personally, for me, there should be a bit of a balance, or at least take that in consideration with your team members. There are also some, like especially in the more, I would say maybe in a more traditional project approach. So there's also some that might see pairing as wasteful, as they see it as, oh, I'm paying two people to produce the same output, as one. So convincing some people of the benefits can be a challenge. It shouldn't stop us, all these challenges shouldn't stop us from paired programming, as the benefits, in my opinion, outweigh the challenges. But it's wise to take those challenges in consideration and be aware that they're there. So paired programming can be considered as a crucial practice to create high quality, to create maintainable software in a sustainable way. It is, however, probably not very helpful to really take a dogmatic approach. So like always pair on everything. There may not be the same return on investment on, for example, like simpler tasks, pairing on simple tasks that you've already done, like how often? Numerous times. So how exactly pair programming can be effective for some teams, how often and how much they should pair and for which tasks, etc. It just will depend on context. So below this image, you will see here a URL. It goes to an article that Birgitta Buckler and Nina Siesager, so they're both developers, they've written a great article about pairing and all the flavors that you have, the challenges, the pitfalls, and also tips and tricks. So I could really recommend to go and have a look at it. So we come to mobbing. So another practice that I ran into. So mob programming, also often called mobbing, that's how Woody Zell describes an all-team approach. So Woody Zell has written an experience report named Mob Programming, a Whole Team Approach. And if you go to the Agile Alliance website, you can find it there, or you can just Google it there. And he really tells quite in detail how his team used mob programming, what benefits it gave them, what challenges they had, etc. So it's definitely worth having a look. So I personally was first introduced to mob programming when I was visiting a company in Japan as part of, the traveling journey that we did in 2018. So we visited a company. I saw one big desk with a big screen, one keyboard, and the whole team was working around it. A year later, I was lucky to join a mob programming workshop myself, so I could really experience it for myself. And we practiced it. And I must admit, it was quite tough and challenging, but I did enjoy it. It was a very different way of working. In a nutshell, with mob programming, the whole team works on the same thing at the same time, in the same space, and at the same computer, similar to pair programming, but then with the whole team. So while they're using a single computer for writing the code. So aside from coding, the team collaborates on what is needed to really create a valuable single unit. Yeah. So ranging from defining what work is needed, like product backlog items, design, test, deploy, release, and working directly with customers. I'll briefly really mention a few other ones. So beyond the technical approach of TDD, which we discussed, there's also test-first approaches. There's behavior-driven development, accepted test-driven development, and specification by example. These all help drive development through defining the test, or how we expect the functionality to work first. So again, this reduces the misunderstandings, it improves the communication while blurring the line between requester, programmer, and tester. So next I want to talk about continuous, well, I would almost say continuous everything, but that would maybe go too far. So let's talk about continuous integration, continuous delivery, and continuous deployment. These all help us to build in quality. So I talked a bit earlier about shifting to the left. So these all help us to shift things to the left, as they say, by delivering and validating earlier. Nowadays, these practices are more often mentioned as part of DevOps, but they have been around for longer as they were part of extreme programming, so XP. Continuous integration is the practice of a programmer continually integrating their changes with others. So working for many days in isolation in a separate branch, that is not continuous integration. To do continuous integration well, each programmer should be integrating their changes into a shared branch several times a day. And progress is made in a series of small steps, and integration issues are minimalized because of that. Now, think of a team of developers working in a 1-month sprint. And let's say that they would check in everything, or they would merge in their work just a few days before the end of the sprint. If then things break, it's much harder to work through like 1 month's worth of work of all those people across the team, opposed to very small changes, finding out. Combined with automated builds where automated tests are run regularly, it actually reduces risk of bugs, it reduces the pain of integration, it improves quality, and it increases the need for massive regression test phases, as I had to do, as I mentioned earlier, with my team, like my very first team. So with good engineering practices, releases become a non-event. So no overnight builds where the whole website has to go down for hours and hours. The need for out-of-hours deployments, just like we did, just goes out of the way. This also gives the advantage of releasing smaller increments earlier and more often, allowing the team to deliver value earlier and also get earlier feedback. So talked a bit about continuous integration, talked a bit about releasing. So let's talk about continuous delivery. So continuous delivery is a state of having the latest version of the code that's ready to be deployed at all times. I sometimes say it's more like, let's say that tomorrow the product owner stands at your desk and say, I want to push the button and release this. And you go like, oh yeah, okay, no problem. So as Martin Fowler puts it, much better than I just did, he says, a stakeholder asks for any version of your code to be deployed to any environment and nobody panics. Now, of course, again, this really requires good engineering practices to be in place. Yeah, so good quality automated test suites that are well maintained, automated builds, build pipelines set up for all the environments, and continuous integration servers in place with continuous integration being followed, yeah, properly. So continuous integration is step towards continuous delivery. And then beyond continuous delivery lies continuous deployment. While continuous delivery is about having the latest version of the code ready to be deployed at all times, with continuous deployment, the deployment happens kind of automatically. This could go as far as at the point a programmer checks in a piece of code, and provided it passes the suite of integration automated testing processes, it automatically builds and deploys to target environments, and that does include production. So one example is Amazon. They are very famous for deploying to production every so many seconds. I think I read somewhere 11.7 seconds. And that was the last time they shared their statistics, which was several years ago. So I'm not sure what it is now. This does allow them to deliver value, test ideas, get feedback, roll back, you know, if they need at a really pace. And while we understand that not everyone can be Amazon, it does show the levels of agility that can be achieved with the right investment in these practices. Now, many of these practices could be viewed as daunting to implement. Sometimes people see them as expensive. And as I think already mentioned earlier, it's like they seem to get actually in the way of delivering stuff. However, I would argue that building in quality and enabling sustainable development long into the future is essential, and it's truly the professional thing to do. While putting these things in may seem to slow us down, it actually speeds us up in the long run. Yeah. For those, who are still really hung up on speed. What should not be an option, though, is that we're trading quality for speed. So agile engineering practices are essential to achieve agility, as they allow us to shorten delivery cycles, get early feedback. They allow us to validate our assumptions. I once heard someone say, and I don't know who it was, otherwise I would, give them credit, but I heard someone once saying, value is only assumption until it's in the hands of the customer. Yeah, so it's only an assumption. So value is only an assumption until it's in the hand of the customer, because you don't know until the customer actually uses how valuable it will be for them. Yeah. So it helps us to validate our assumption. Those practices allow us to react quicker to changing customer behaviors and fast changing market trends. They avoid us from getting buried in this mountain of technical debt that, at one time we just can't pay back anymore. So it really seems to be quite an obvious choice to invest in good day-to-day agile practices, you would say. But surprisingly, many companies, though having good intentions, end up taking shortcuts to deliver fast. And advocates of these, engineering practices often struggle to convince managers, co-workers, stakeholders, etc., of how important it is. It is important that everyone truly understands the importance of investing in good engineering practices and the impact of it on agility if you don't do it. Creating a shared understanding of the challenges that teams may face, can, allow people to make more informed and balanced decision of what they should invest in a certain given time. Also, I like to frame changes as experiments, trying out or investigating a certain practice for a few iterations and see how it can help can be a start. Often when people are more exposed to the practice, they can see the benefits for themselves and it becomes less daunting. In companies like that I've seen here in the UK, I did notice that people are often rewarded by given promotions and they progress up like the vertical corporate ladder. Yeah. So if people want a significant pay rise or other extra benefits, it often has to involve getting a promotion. In many cases, this involves people taking on management responsibilities. And then good technical people spend more of their time doing non-technical things. I see less companies rewarding people who grow more like horizontally. So it's kind of this horizontal development ladder. What I mean by this is, people learning new skills, expanding their knowledge of their craft, keeping up with the latest technology trends, including good engineering practices. And this growth does not end with just mastering technical craft. It's people that share their knowledge, mentor others, and drive their teams and organizations to make good technology choices aligned with the organizational strategy. And those things should also be valued, just as much as climbing up that vertical ladder. After all, it's all these things that can give a company competitive edge. So why not reward people based on the value they bring to the company, regardless where they are in the hierarchy? This almost brings me to the end of my talk. And there's one more thing I want to share. So let's finish on that. In a domain such as software development, it may be questionable if agile without the underlying agile practices is actually agile at all. Yeah. If we want sustainability, robustness, quality, customer service, fitness for purpose, and true agility, there needs to be continuous improvement in good engineering practices and good engineers. Thank you very much